Now let's try exercise 10.1. Let's begin with its first question, that is, how many tangents can a circle have? Let's try drawing a lot of tangents on a circle. Okay, this is a circle. I'll try drawing tangents on it. One here, one here, one here, one here, one here, one here, one here. I can try a lot of them. But that's the point here. How many? How many tangents can you draw on to a circle? Well, if you look at the definition of a circle, it's a collection of points that are at a constant distance from its center, right? And these points, they are very, very tiny, so tiny that they're almost dimensionless. Their size is close to zero. So you can put down a dot. You can put down a dot next to it, and next to it, and next to it, and let's say you put down 5,000 dots, and they are so tiny, so small, that even if you put down 5,000 of them, maybe you don't see even a speck of a circle because they are so tiny. And it doesn't matter how you can put one dot next to other, then next to it, then next to it, and you can keep putting dots like dots on dots making a circle, but there is always room for dot because they are so tiny that you never get close to completing the circle. You see, they're so tiny that I can draw one more. So it just seems like they're very, very large. It's not that I won't make a circle, but they're so tiny that I will need a very large number of points to make a circle, and that large seems like it's impossible to get to, or at least calculated, because their points are so tiny. So I can say they are almost infinite. Okay, so if they are infinite, then I can draw one tangent to a point. So if there are infinite number of points on a circle, then I can draw infinite number of tangents, right? So the answer would be infinite. Now let's see what the second question is. It is fill in the blanks. So the first question is, a tangent to a circle intersects it in points. A tangent to a circle, it doesn't intersect actually. It just touches a point and moves away from it. But anyway, we get the point. Maybe the question wants to there was some, it seems like, error in framing it. So we draw a tangent and we take a point on the circle, and we know that a line that a point on the circle, we can draw only one tangent to it. So the answer would be 1. Then let's take the second question in it. A line intersecting circle into points is called a secant, right? These are the 2 points, these blinking pink points. It's a secant. We already know it from basics section. We covered secant there. It's a point that intersects the circle at 2 points. Okay, when a circle can have parallel tangents at the most. We did it under an activity. We drew a secant passing somewhere around the middle of the circle, and then we drew parallel lines left and right to it, and then we tried moving out of the circle drawing these parallel lines, and then we got to a point where we were just touching the circle, and there we concluded that because these are parallel lines, we can only move in, we from this line passing through these circles, from the circle, from the somewhere around middle of the circle, we could only move in 2 directions drawing parallel lines to it, and then we would if we kept moving out of the circle, somewhere we would touch the point before just going off the circle. We would touch a point on the circle where these lines would be make a tangent to the circle. So I can draw only two parallel lines, and those two parallel lines, if they touch the circle at one point, so I made two parallel lines like that. So I can draw only two parallel tangents like this. And then the common point of a tangent to a circle, and the circle is called, what is a point that is common between the circle and the tangent? It is the point of contact. That's where they touch. That's what it is. It's a point of contact. Now let's do the question number 3. The third question is, a tangent PQ at a point P of radius 5 cm meets the line through the center O at a point Q, so that OQ equals 12 cm. Length of PQ is. So we have 4 options. Let's try drawing a circle. It says a tangent PQ at point P of a circle. So we want to draw a tangent that touches the circle at point P here, of radius 5 cm, meets the line through the center O at point Q. So we have a point Q here. When I draw a line through the center, that's the center O. If I draw a line through this, it will meet it at point Q. Okay, and then I draw a line connecting center O and P, and I know that a line that connects the center of the circle to the point of contact is perpendicular to it, so it's going to be 90 degrees, and the length of OQ is given here, 12 centimeter, and then I know the radius of this circle is 5 centimeter. Here it is, and I can use Pythagoras theorem to calculate the length of PQ. So it should be hypotenuse square equals square of the length of perpendicular plus the square of the length of its base. So that's OQ square equals OP square plus PQ squared. So that's where it is. It's OQ is 12 centimeter, so it's 12 squared equals OP squared. So OP is 5 centimeters, so 5 squared plus PQ squared. Now I can rearrange this and solve for PQ. It comes out to be square root of 119 centimeter. So the option D is correct here. Now let's take question, it should be question number 4. I mistyped it. Question number should be question 4. Draw a circle and 2 lines parallel to a given line such that one is a tangent and the other a secant to the circle. So it wants us to first draw a line, then draw 2 lines, one that is tangent, one that is a secant to a circle, but these should be parallel. So we can have 2 cases. First one is the line lies outside the circle, and then the second case, the line lies inside the circle. So I'll do it for only case 1. You can do it by yourself for case 2. It's not very different, almost similar. You just need to draw a line inside the circle. Let's try this. I draw a circle, then I draw a line outside the circle. I'm doing it for case 1. And then I connect a point on the circle where I want to draw a tangent to this line. But I make sure that this the line that connects the point on the circle is perpendicular from the line outside the circle. So here it is. I point I connect a point on the circle, this dotted blue line, and this line is perpendicular to the line out to the black line outside the circle. And why I want to make why I want to make it this line a perpendicular, or you'll see. Then I take to another point on the line. Okay, I take this line I drew from the line that touches this circle. I take it its distance, its length. Then I draw similar lines from 2 points on the black line of the similar length and perpendicular. Why am I doing this? Because I just want to make it easy, because these lines are perpendicular and of the same distance, of the same length that I drew from this to this circle. So if I draw these lines from these two lines from the black line, and I connect the endpoints of these lines, then the line that I get would be parallel to this line outside the circle. That's how I do it. Here's the line. I connect the endpoints of these two lines. Okay, so this line is going to be parallel to it. Why? Because this line is perpendicular. All these lines are perpendicular to the line outside the circle, and you know that between two parallel lines the distance is always constant, so that makes my job easy. And I want to draw a second, that means a line that passes through the circle. So I extend these lines inside and extend these lines to the extent that they go inside the circle, so that I could connect the endpoints of these lines and then draw a second easily. Okay, I extend this line, then I extend this line, then this one, and then I connect the endpoints of these lines, and now I have a second inside that's a line that intersects the circle at 2 points. Now that's a second. So we are done with exercise 10.1. Now we'll do exercise 10.2.